Welcome back to Stardust Discovery. Today, I want us to take a deep breath and think about some of the basic, powerful forces that we encounter on all of the topics we'll be talking about on this platform. So, this is really for new members, new people that are finding this page. I thought that it might be useful to get everyone on speed about some of the basic concepts surrounding most of the topics we discussed. And so today I would like us to look at the topic light and gravity. So the question I'm asking, are they the most powerful forces of the universe? I did not answer yes or no. This is the question I am asking. However, for us to get started, I would like you to subscribe to this YouTube channel. It doesn't bite, really. This page is to create some content around everything around us, helping you to understand what is going on, why things are happening the way they happen, especially those seemingly mysterious phenomenon. For example, eclipses. Why do we get dark at night? Why are all of these things happening? Why do we see all the stars at night? All of these, so many questions, stars at night, all of this probably have been looking for answers to. Now, this is what this page is about. So you might, do your friends some favor by sending them the link, get them to join and also subscribe. And while you're at it, feel free to comment and let me know what you think. Also like this video if you do like it. Okay, so let's get started. So today, I want us to do something different. So why not join me into a pretend spaceship for us to have this conversation? So just like you can see on your screen, let's get on board. So we are joining this conversation by entering this pretend spaceship, and we will drive and leave the Earth. We get into space, explore the space, and we'll come back. So let's get started. Okay, I will start the story with the discussion of light. Okay, so as we look up the sky, or as we are already moving out of Earth, going into space, I'm sure you see glows of different objects. They are seeing different point sources, but you do notice they are glowing. You see some very close by ones like the sun. You can see the moon. Some of them reflecting light from another object. However, you're seeing light. Okay, you are seeing light all over the place. So what is light? Now, light is like a messenger. Light is like a guide, telling us stories about objects that they are coming from. But what is really light? So for us to understand light, I would like us to go back to the basics. Really, light is just a simple way of saying electromagnetic energy or wave. And this is just the combination of magnetic energy and electrical energy. But what is spectacular about this energy is the fact that it's on a spectrum. So when you hear that something is on a spectrum, it means there are different parts of it, okay? And there is usually two extremes of the spectrum. In this case, we use wavelengths to quantify the spectrum. So we have the long wavelength and the short wavelength. And in this case, the radio is the longest wavelength and the gamma radiation is the shortest wavelength. So what it means is that this is reducing wavelengths. We are going from radio downwards, we are reducing wavelengths, okay? Now, on Earth, these different wavelengths of light, they play different roles. They are very useful in our day-to-day life. As you can see, dealing with the radio, it is because of the radiation in the radio wavelengths that we are able to make telephone calls, watch DSTV, watch cables, Netflix, all of these things that we do thanks to radio radiation. We also have our food get warm these days with microwave. We have television remote, and even our bodies, releasing heat because of the infrared radiation we emit. We also can see because of the visible light, and actually our eyes is able to see in that wavelength. The visible light or the optical light is useful for seeing. That is the main reason we are able to see. Even the sun, even though it's emitting the different wavelengths of light, the one that allows us to see is the visible. Then we have the ultraviolet, which is called UV, also released from the sun naturally, but there are also synthetic ways of producing these things because of they are used in various industries, just like X-ray. So many of you have used it to, check your bones and all of those things. So these are very useful, for new use of the light or electromagnetic energy in their different wavelengths. Now, we want to take a deep breath out of the earth. Remember, we are actually out of the earth now as we are moving into space. I'm sure there are objects you are able to recognize, okay? Even with your eyes, you are able to see some objects like we'll be seeing shortly. But there is a limit to what your eyes can see. And at that point, you will need some aid, like the binoculars, to see much further objects, or at least see them more precisely to the details. Okay. So what do you see when you look up? There are different objects that we can see with our naked eye and also with binoculars. For example, clusters of stars. So you can easily see those from the optical sky. You can see the moon, which is the Earth's moon. You can also see the planets of our solar system, with the very prominent ones like Saturn, with the ring, Jupiter, and some very prominent ones, even Venus. You can also see them. Now, so many of you are concerned with the Orion constellation. You can see that constellation, but if you have a high resolution camera, you can even see this cloud of gas and dust embedded in it, which is called the nebula. Then you can see some galaxies, but most importantly, the closest one to us, which is called the Andromeda galaxy. You can see that in the night sky. You can also see some binary star systems, especially the closest one to us, which is the Alpha Centauri system. You do see those ones as well. Now, our Milky Way, which is our own galaxy, because we are on it, we can't see the full picture. However, we can see some parts, and so most times you will see this band. All of this band is just one of the arms of the Milky Way galaxy. It tells you how huge our galaxy is. And then there are other objects like comets and asteroids, some of the remnants of formation of our solar system that you could see as well. Recently, we have one of them crossing the path of Toronto, and with detail. It was so beautiful for days and visible to see. Now, all of these you can see with your naked eye, but like I mentioned earlier, there is a limit to what we can see, even with binoculars. So what do we do then? How do we get into seeing very distant galaxies, very distant objects? And that is why telescopes are useful. Now, telescopes have been designed to aid the eyes so that we can study the universe. We can see much distant objects than our eyes could see. It helps to even look at other wavelengths. So typically our eyes can only see only in one wavelength, which is the visible or the optical wavelength. But when you are using the telescope, you could decide to look for a telescope that you see in another wavelength, and that helps you see in that wavelength. Now, why do we care about seeing another wavelength? Why don't we just stick to only the visible wavelength? Just like we have seen, looking at the Earth, there are different views of the different spectrum. Now, that same way, when we are looking at different wavelengths, we see different aspects of the same object. So it's like fixing a puzzle. So when you are looking at something from all directions, from different angles, you learn different things, which will give you a wholesome experience as opposed to looking only with one perspective. Okay, so which is why it's useful to look in all wavelengths. Now, just the way we see, our eyes is only able to see indivisible. This telescope that I'm showing is also able to see what the eye can see. However, it will do a better job because it has a bigger diameter. So the larger the diameter of any telescope, the better it will see and resolve distant objects, which means it will give you more detail, okay, than a smaller diameter telescope. Now, this is even portable. You can buy this, use it for your personal use. This is like very, very easy to get. But we also have the very huge ones. This is what scientists use. Astronomers use this to do actual research. It's not movable, usually in one place inside a dome, very, very big. Okay. Now, this will give you a good result by giving you details of what you are seeing. Still in the optical, remember. However, if you want to, get even a much better result, you want to leave the Earth entirely, and that is why space telescopes are very, very useful, because in that optical wavelength, we get a lot of blurriness in our images. So the Earth atmosphere is made up of many, many layers, and those layers affects the image you get. So in order to avoid that, you want to leave the Earth atmosphere. And then when you do that by launching your telescope into space, you have increased your image resolution, by a lot. Okay? So which is why that is so useful. Now there are other wavelength telescopes, like I mentioned earlier. You can see in the radio we have this type of dish that looks like satellite dish. Those are so useful. This is from the very prominent, very large array in Hawaii. There is also the JWST, the latest infrared telescope in space. There is Chandra telescope also in space. It's an X-ray telescope. Now, what kind of object does this, see? What does it look like? What are the differences? Now, this is an image of a giant molecular cloud, which is a mixture of gas and dust that are remnants from star formation from the universe in general. They have formed this clump together, and by gravity they will collapse to continue forming stars. Now, as you can see, they are looking different in the different wavelengths, which is the different perspective that I was talking about. So when you get all these details, you put them together to make sense of what you're seeing. So from these different images, we learn star formation, we learn things like the properties or the makeup of these stars. What are really the things that end up forming these stars? Okay, so there's so much we learn just by putting these images together. Another object of interest is a galaxy. This is a galaxy that is no longer forming stars. It's actually called an elliptical galaxy. Also because of the shape, looks like an ellipse. But when you look at it in the X-ray, you notice that it's showing a very bright spot at the middle, which is where the supermassive black hole, which is usually found at the center of all galaxies, is located. So it seems to be very sensitive to the X radiation, which is why you have this image looking this way. Okay, so quite a hotspot at the center. But in the radio, just have that central point source, but then you can notice these jets. So that central source can release jets in two directions, and it's visible in the radio. Now, while we can learn different things just by this different perspective of the same object, I also want to highlight that the spelling of different stories at different times of the same object. So light travels with time, okay, and the longest wavelength will take longer time to get to us, while the short wavelength light will take shorter time to get to us. So what that means is that when you're looking at an object in a short wavelength, like in the optical, what you're seeing is the most recent version of that object. But when you're looking at it in the radio wavelength, for example, you are looking at the oldest version. So what that means is that when you're looking at the light in that wavelength, you are looking back in time. So it's telling you an old story, which is very interesting. Okay.